Hey guys, today we are looking at arc lengths and sectors of a circle. So we're looking at these formulas today because in order to do these formulas, it's really important that we are in radians. So we had to do our notes over radians first, which is what we did last class period. Your formula for arc length is S is equal to R times theta, where R is the radius and theta is the angle measure. So let's just look at a couple examples of this. Example 1 says a circle has a radius of 18.2 centimeters. Find the length of the arc intercepted by a central angle with measures 3 pi over 8 radians. And then it says round to the nearest thousandth. So if I'm looking at my formula, it would be S is equal to R theta. Our radius here is 18.20. Then our theta is the 3 pi over 8. We would take that and plug it into our calculator. So let me pull my calculator up. Okay, there we go. So again, it's really important that we are in radian mode. So check and make sure we're in radian mode. And then we can just plug it into our calculator. So I'm going to do 18.20 times, and then that 3 pi over 8. Oop, there we go. And we get 21.44. And this is a length, it's like a measure around the circle. So 21.441 centimeters. And it's this little area, or not area, this little section of the circle right here. So it's a part of their circumference. So our unit of measure would just be centimeters. It's just that little section that goes that little bit around the circle. Okay. Example 2 says a circle has a radius of 18.20 centimeters. This time it gives us an arc that has a central angle with 144 degrees. So this is where you have to be careful. We do have to be in radians. And so I have to come over here on the side and I have to take that 144 degrees and convert it to radians. And so that's what this caution box over here says. It says when the formula is applied, the theta must be expressed in radians. So if you remember from last class period, to change this to radians, we're going to multiply it by pi over 180. So when I do that, I get 144 pi over 180, which would simplify to 4 pi over 5. And then that is what I can then plug into my formula. So this would be the theta that I would plug into my formula and use. So when I have S is equal to R theta, I would have 18.20 times the 4 pi over 5. I've got to change whatever degree they give me and make it radians. So 18.20 times, and then doing my fraction, it's going to be 4 pi over 5. And for this one, rounding to the nearest thousandth again, I get 45.742 centimeters. All right. And it can be applied to word problems. So that's what we got in example 3. Example 3 says latitude gives the measure of a central angle with the vertex at Earth's center, whose initial side goes through the equator and whose terminal side goes through the given location. Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, and that of Los Angeles is 34 degrees north. The N in this means north of the equator. So the radius of Earth is about 6,400 kilometers. Find the north-south distance between the two cities and round to the nearest thousandth. So what I'm trying to do here, and I'm going to zoom in on the picture, is I'm trying to find the distance between the two which would be this arc length right here. So it looks really, really small, but we're trying to find the distance between the two cities right there. And if you look, it already did the subtraction for us in the picture. It tells us that the difference between the two is 6 degrees. But remember, we can't be in degrees here. So I'm going to take that 6 degrees and I'm going to multiply it by pi over 180. We convert it into my radians. So I get 6 pi over 180, which simplifies to pi over 30. And that's going to be what I plug into my calculator. And the reason I keep doing this as fractions and not actually plugging this part into the calculator also has to do what we talked about in a previous lesson. Remember the significant digit part that we talked about in, I think it was last unit, the very, very end of the last unit, that your answer is only as good as your most significant or least significant digit. So if I were to take pi over 30 and plug it into my calculator and round it too early, I'm going to get an answer that is rounded too early and is not going to be a correct answer. So you want to try and keep things as exact as possible. So keep it as a fraction for as long as possible and plug it into your calculator at the very, very last second so that you're not getting an answer that's off because you rounded your answer too early. So my equation is S is equal to R theta. The radius of the Earth is about 6,400 kilometers. So I'm going to do 6,400 times that theta I just found, which is pi over 30. Plug it all into my calculator. So 6,400 times my, oh,
Get ready to refresh your home and shop the
pause the ad, pause for the ad, times my pi over 30. There we go. And it's going to give me 670 point. This one also says round to the nearest thousandth, so 206. And we are dealing in kilometers this time. So 670.206 kilometers is the distance between those two cities. And another word problem, another applications problem, this time some basketball. It says the figure shows one end of a game court with a three-point line colored red. What is the total length of the three-point line to the nearest foot? So I'm going to zoom in on the picture here. And this part of my three-point line right here that I'm highlighting pink is 13 feet, which means this part over here that now I'm going to kind of color in blue is also going to be 13 feet. So I've got those two ends. The part that I now need to figure out is this arc here. And so when I'm trying to figure out the arc, that's where I'm going to have to use my arc length formula. So this 24.75 is telling me the radius right here. We've got a nice angle measure, but the angle measure is in degrees instead of radians. So I'm going to come over here and I'm going to take that 139.77 and I'm going to multiply it by pi over 180. That's going to get me 139.77 pi over 180. That one doesn't simplify nicely like our previous ones did. So to find the full length of that three-point line that goes all the way around, I've got 13, the first segment on the left, plus 13, the other segment on the right, plus, and then my arc length. My arc length is my radius, so the 24.75 times my angle, which would be that 139.77 pi over 180. And I can plug that whole thing into my calculator. It says rounding it to the nearest foot. When I plug it in, I'm going to have 13 plus 13 plus 24.75 times 139.77 pi over 180. It's going to pop out 86.376, which would round to 86 feet. So that's how we find arc lengths. Did a couple examples and a couple word problems. The next formula is finding the sector of a circle, which is finding the area that goes inside with that arc length. When we talk about sectors of circles, I think about it like the pizza piece or the pie piece. If we're talking about like the full circle being a full pizza or a full pie, you're looking at like that slice of pizza or that slice of the pie. And the formula for that is 1/2 radius squared times theta. We got two problems we're going to do here. So it says a center pivot irrigation system provides water to a sector-shaped field with the measure shown in the figure. Find the area of the field and round it to the nearest thousandth as needed. So it's this kind of triangle shape here. Ooh, and this triangle-ish shape, but the bottom's curved, so that's why we're using a sector instead of just a triangle. And so we are going to do 1/2 times my radius, which is 321 meters squared, times my theta, but my theta is 15 degrees. And just like with my arc length, my sector needs to have my theta in radians. So I got to take that 15 degrees and I got to multiply it by pi over 180. It's going to give me 15 pi over 180, which is going to simplify down to pi over 12. So that's what I can plug into my formula. So really what the most complicated part of today's notes is remembering that if it is a degree, you got to switch it to a radian before you plug it into your formula, and then plug it into the formula and plug it into the calculator. So 1/2 times 321 squared times my pi over 12 that I just found. Plug all that into the calculator, gives me a really big number. Rounding to the nearest thousandth is 13,488.035. And this time we are talking about an area, so it is going to be meters squared for my unit on the end, or square meters, however you would like to say that. 13,488.035 square meters. And then our last example kind of goes with how I think about the sector of a circle is a slice of pizza. Ashley has a pizza that she wants to share with her 5 friends. If the pizza is 15 inches in diameter and each person will get one slice, what is the area of each slice? And round to the nearest hundredth as needed. So if you have Ashley and her 5 friends, you got to think about the fact that that is Ashley and 5 people, so that, or it's 6 people total. So we're trying to divide it into 6 sections. So I'm going to take my whole 2 pi all the way around the circle and divide it by 6, which means that my angle measure would be pi over 3. 15 also is the diameter here. So my radius would be 15 over 2. I've got my theta, I've got my radius, and now I just gotta plug it in. So I'm going to have 1/2 times that 15 halves squared times the pi over 3. So 1/2, a lot of fractions this time. And another app.
Here's an app your teacher doesn't want you to know about. If you have homework and you don't know the correct answers, just scan it with the
15 halves squared, and then pi over 3. So when I plug all that in, it says round to the nearest hundredth as needed. So I get 29.452, and it is inches squared. Pretty big piece of pizza. Right, that is it for this set of notes. Make sure you do your homework assignment that goes with this in my math lab. And you guys have a good day.